Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
A significant change is occurring in how software is built, with AI agents moving from mere assistants to taking on increasingly autonomous coding tasks. But this convenience, according to new analysis, comes with a stark warning. It is creating an entirely new, rapidly expanding attack surface that traditional security measures simply are not equipped to handle.
Exactly. The report suggests the issue is not just about new vulnerabilities in AI-generated code, but entirely new classes of threats stemming from the agents themselves, their permissions, their autonomy, and their constant interaction with critical development environments. It is a systemic risk.
Before exploring how these agents are reshaping the threat landscape and potential solutions, the latest developments on the AI tooling radar will be reviewed. What has been buzzing on the wires this week?
Kicking off with OpenAI's Codex lineage, there has been chatter about a new internal beta codenamed Project Weaver, which reportedly offers enhanced multi-file project context awareness. The claim is that it can reason across entire code bases to suggest refactors, not just individual functions.
That suggests a significant advancement for larger-scale code generation. The practical implication is that developers might trust it with more complex, interconnected tasks, potentially increasing its operational footprint.
Precisely. More autonomy, more reach. Over at Anthropic, Claude 3.5 Sonnet code has apparently introduced what is being called Guardrail Light for dependency management within generated code. It is meant to flag known vulnerable packages before integration.
A proactive step, then, attempting to address supply chain risks at the source. It is an interesting move to incorporate that security consideration directly into the model's output.
It is. Meanwhile, Google's Gemini Code Assist has deepened its integration, now directly available within VS Code's remote development feature. This means seamless AI assistance for developers working on cloud-hosted or containerized environments.
This represents a clear push for widespread adoption in enterprise settings. The convenience factor is significant, but it also means Gemini could be operating in even more privileged and distributed contexts.
Right. GitHub Copilot Business also rolled out an update this week, adding real-time vulnerability scanning for its generated code suggestions, powered by SemGrep. It is an attempt to catch common security flaws as the code is being written.
This adds another layer of defense directly integrated into the developer workflow, reflecting the growing recognition that AI-generated code itself can carry security debt.
Absolutely. Moving to the IDEs, Cursor has shipped an experimental auto-refactor agent feature. It allows the AI to autonomously propose and apply refactoring changes across a project based on performance or maintainability goals.
An autonomous refactoring agent? This expands the scope of tasks developers might delegate to an AI. It implies significant trust in the agent's understanding of code semantics and potential side effects.
Indeed. And finally, a smaller player, Windsurf, has launched what is being called a secure dependency agent. This tool is designed to continuously monitor and alert on supply chain risks, specifically within CI/CD pipelines, acting as a dedicated watchdog for third-party libraries.
This is a more niche, specialized agent focused purely on one aspect of the security chain. It suggests the problem space is becoming so complex that dedicated AI tools are emerging just to manage the security of other AI tools.
That is the takeaway. The security landscape for AI coding tools is fragmenting, with both integrated features and specialized agents attempting to keep pace with the evolving risks.
The evolving risk is the focus of today's discussion. The source material highlights an attack surface explosion driven by semi-autonomous agents. What exactly does that phrase mean in this context?
It is essentially the significant expansion of potential entry points and vulnerabilities that malicious actors can exploit within a system. Traditionally, attack surfaces were considered in terms of networks, operating systems, or applications. But now, with semi-autonomous AI coding agents, entities are being introduced that can make decisions, execute code, and interact with various system components, often with elevated privileges, creating entirely new avenues for attack.
So it is not just that the code they generate might have bugs, it is the agents themselves that become targets.
Exactly. Think of it like this. Previously, a malicious actor might try to exploit a bug in a compiler or a developer's machine. Now, they can try to trick the AI agent itself into doing their bidding, or exploit a weakness in its execution environment. These agents are increasingly embedded in development workflows, from writing code to deploying it, granting them access to sensitive intellectual property and infrastructure.
And the semi-autonomous part of that is crucial. These are not just simple script executors, they have a degree of independent decision-making.
That is right. They can interpret prompts, access external tools, search databases, and even self-correct. This autonomy is their strength, but it is also their greatest security weakness. If an agent is designed to, say, find and fix bugs across a codebase, it might need broad read and write access. If that agent can be compromised, then that broad access becomes a direct path for an attacker.
So what are some of these new classes of threats or attack vectors that these agents introduce? The report details several.
One of the most prominent is prompt injection. This is not just about getting the agent to say something unexpected. It is about getting it to do something it should not. An attacker might embed malicious instructions within seemingly innocuous comments in code, or within a test file that the agent is tasked with analyzing. The agent, in its attempt to be helpful, might then execute those instructions, potentially deleting files, exfiltrating data, or introducing backdoors.
So like a Trojan horse, but instead of a program, it is a hidden instruction within a seemingly legitimate prompt or piece of code that the agent then dutifully follows.
That is a very apt analogy. Another major concern is supply chain attacks, but with an AI twist. Agents are often tasked with pulling in external libraries or dependencies. If an attacker poisons a widely used open-source package and an AI agent autonomously adds it to a project, the malicious code bypasses human review entirely. The agent might not even recognize the intent because it's focused on functional requirements.
The automation of ingesting potentially compromised dependencies presents a significant concern. This makes the classic supply chain problem even faster and harder to detect.
It does. Then there is the risk of data exfiltration. An agent, especially one tasked with, say, summarizing code or generating documentation, might inadvertently, or deliberately if compromised, expose sensitive intellectual property or API keys by incorporating them into public-facing outputs or sending them to an attacker-controlled endpoint. Its function is to process and communicate information, which can be weaponized.
So its helpfulness can become its downfall. It is designed to understand and reproduce information, which is exactly what an attacker might exploit with sensitive data.
Exactly. Another risk is privilege escalation and lateral movement. If an agent is running with elevated permissions on a developer's workstation and it gets compromised through, say, a prompt injection, that agent could then use its permissions to access other systems, move laterally across the network, or even escalate its own privileges further, essentially acting as a proxy for the attacker. The report emphasizes that these agents often run in environments with high trust and significant access.
So the developer's workstation, which is already a high-value target, now has an increasingly autonomous entity operating within it, potentially with significant access. This raises a key question: why are not traditional security tools enough to protect against these new threats?
Traditional security tools like firewalls, antivirus, or even static application security testing are primarily designed to detect known malware signatures, network anomalies, or vulnerabilities in finished code. They operate on different assumptions. They do not understand the nuances of prompt injection, for instance, where the malicious payload is not a virus, but a cleverly crafted instruction that the AI interprets as legitimate.
So they are looking for a specific type of threat, and these agents are creating an entirely new category of threat that slips past those established filters.
That is precisely it. Moreover, traditional tools lack visibility into the internal reasoning and decision-making processes of AI agents. They can see an agent executing a command, but they cannot easily discern why it executed that command, or if it was prompted maliciously. This makes detecting novel attacks incredibly difficult. It is like trying to secure a building by only watching who enters and leaves, without any insight into what is happening inside once they are in.
So the why behind the action is critical and current tools are not equipped to ask it. Given this expanded attack surface and the inadequacy of existing tools, what does the report suggest about putting a leash on these agents? What are the proposed solutions or mitigation strategies?
The core idea is to implement agent-specific security measures and a robust framework for governance. This begins with the principle of least privilege. Agents should only have the minimum permissions necessary to perform their assigned task, and those permissions should be narrowly scoped. If an agent is only supposed to write documentation, it should not have file deletion capabilities.
Limiting an agent's blast radius, essentially. If an agent goes rogue, it cannot do as much damage.
Exactly. Beyond that, runtime monitoring becomes critical. This involves observing agent behavior in real time, looking for anomalous actions that deviate from its expected operational profile. For example, if a code-generating agent suddenly tries to access network resources it has never touched before, that is a red flag. This requires specialized tools that understand agent intent and execution.
So it is not just about what code it generates, but how it is behaving while generating it. Is it interacting with the system in unexpected ways?
Precisely. Another key strategy is sandboxing and isolation. Running agents in isolated environments with strict resource limitations can prevent them from accessing sensitive data or systems even if compromised. This creates a protective barrier, much like containerization for traditional applications, but tailored for agent workflows.
So effectively putting them in a secure playpen where their potential for mischief is contained.
That is a very good way to visualize it. The report also emphasizes robust policy enforcement. This means defining clear, machine-readable policies that dictate what an agent can and cannot do, what data it can access, and what external services it can call. These policies need to be continuously updated and automatically enforced.
This implies a rule book for the agent, written in a language it can understand, that is constantly being checked.
And finally, the human element remains paramount. The report underscores the need for human oversight and intervention, especially for critical or sensitive tasks. This means implementing approval workflows for agent-generated code, continuous auditing of agent activities, and training developers to recognize and mitigate agent-specific threats, like prompt injection. It's not about fully automating security away, it's about equipping humans with better tools to monitor and control the automation.
So the leash is not a permanent lockdown, but a set of intelligent controls and monitoring systems designed to maintain oversight and allow for quick intervention when an agent deviates from its intended purpose. This suggests a complex but necessary shift in how security is approached in an AI-driven development world.
It requires a significant reevaluation. Security approaches need to adapt from securing static assets to securing dynamic, autonomous entities that operate within and across systems.
To summarize, what are the 3 to 5 most important insights for listeners to take away from this discussion about AI coding agent security?
First, the rise of semi-autonomous AI coding agents is not just improving developer productivity, it is significantly expanding the attack surface in unprecedented ways, creating new classes of vulnerabilities.
Second, traditional security tools are largely inadequate for detecting and mitigating these new agent-specific threats, such as prompt injection, malicious supply chain integration, or data exfiltration.
Third, effective security for these agents requires a multifaceted approach centered on principles like least privilege, real-time runtime monitoring of agent behavior, and strict sandboxing.
And finally, human oversight, clear policy enforcement, and continuous auditing remain critical. The leash is described as intelligent controls, not outright suppression, ensuring that agents serve their purpose securely rather than exposing users to new risks.
Precisely. The focus is on building trust through verifiable control.
So, with all of this in mind, the more precise question for developers and security teams alike is this. As agents become more autonomous, how can the balance be struck between their immense productivity gains and the escalating security risks they introduce without stifling innovation?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.